Today in AI and cybersecurity, the top takeaway is that AI agents are becoming useful enough to touch real data, but still fragile enough that hostile instructions can ride inside ordinary content. We will cover a reported Grok prompt injection that used encrypted context to leak user data, US warnings about attackers targeting water systems with AI-assisted discovery, an Alation cyberattack investigation, new GitHub security workflow updates, and a major face photo exposure. The practical lesson: do not connect AI tools to sensitive actions without boundaries, logging, and a human verification path. Story 1. Ars Technica reports that researchers demonstrated Grok exfiltrating user data when malicious instructions were hidden in encrypted or encoded material, a technique described as cryptographic context injection. The important confirmed idea is not that one model is uniquely broken. It is that an LLM can be tricked when it is asked to decode, transform, summarize, or follow content that came from an untrusted source. If the model can read private context and can also send text to a tool, a message, a link, or a web page, the attacker may try to bridge those two powers. Why this matters for builders: prompt injection is closer to cross-site scripting than to a bad chatbot answer. The unsafe pattern is mixing trusted instructions, private data, untrusted documents, and external tools inside one agent loop. Google Security Blog has also written about prompt injection threats in the wild and indirect prompt injection risks for complex AI applications with multiple data sources. That official framing is useful. A malicious web page, email, ticket, calendar invite, repository file, or document can become input to the model, even if the user never intended to give that source authority. The defensive model is simple but strict. First, separate data from instructions. A document can be summarized, but it should not be allowed to change system rules, approve payments, reveal secrets, or decide where results are sent. Second, limit tool permissions. An agent that reads customer records should not automatically post to external URLs. Third, add egress controls. If generated text contains secrets, credentials, private identifiers, or unusual encoded payloads, block or review it. Fourth, log the chain: what content entered the model, what tools were called, and what data left the system. That logging is what turns a mysterious AI incident into a diagnosable security event. Story 2. TechCrunch reports that US officials say hackers are targeting internet-connected Siemens controllers used in water facilities around the United States, with AI helping attackers identify vulnerable systems. This is the operational technology version of the same broader trend. Automation reduces the cost of finding old mistakes. A small utility with an exposed controller, a weak password process, or unpatched remote access may now be found faster by actors using search, scripts, and AI-assisted triage. The confirmed advice is still basic security, but the urgency increases when discovery gets cheaper. For water, manufacturing, energy, buildings, and other industrial environments, the checklist is not glamorous. Inventory internet-facing assets. Remove direct public exposure where possible. Segment operational networks from office networks. Require multi-factor authentication for remote access. Patch vendor systems after testing. Monitor for unusual logins and configuration changes. Keep offline backups and incident contacts ready. AI does not need to be super intelligent to matter here. It only has to help attackers search, summarize manuals, write lures, or prioritize targets faster than under-resourced defenders can respond. Story 3. TechCrunch reports that Alation, described as an AI data giant, confirmed unauthorized access to its systems during an incident on Tuesday and said it was investigating the breach. We should not invent details beyond that confirmation. But the category matters. Data catalog, governance, search, and AI data platforms often hold maps of where important information lives. Even when raw data is not confirmed stolen, metadata, integration tokens, account lists, or system diagrams can help an attacker understand an organization. After any incident around a data platform, teams should review credentials, connected sources, API keys, service accounts, logs, and unusual exports. Story 4. GitHub shipped security workflow updates that matter for developers. GitHub changelog says code scanning now has a mitigated dismissal reason for cases where a vulnerability remains in code but external controls reduce risk. That sounds small, but it is important. If a bug still exists, calling it fixed is misleading. If it is protected by a web application firewall, network rule, feature flag, or other compensating control, the risk conversation should say mitigated, not gone. GitHub also says CodeQL 2.26.3 improves GitHub Actions queries and JavaScript modeling, which helps teams find more issues in code and automation workflows. This connects directly to AI coding. As AI agents write more pull requests, update CI files, and generate JavaScript or TypeScript, organizations need scanning that understands modern patterns. The safe workflow is not to ban AI coding. It is to require review, tests, code scanning, dependency scanning, secret scanning, and policy checks before generated changes reach production. Treat the AI assistant like a very fast junior contributor, useful, but not a substitute for controls. Story 5, Ars Technica reports that reverse lookup service clarity check exposed a database containing more than 9 million image files of people faces. The security lesson is privacy persistence. Passwords can be reset. API keys can be rotated. Face images, identity-linked photos, and biometric-adjacent data are much harder to undo once exposed. Any service collecting sensitive personal data should minimize retention, restrict storage access, monitor public buckets and databases, and test whether old datasets are still reachable. For users, the uncomfortable lesson is to be cautious about services that invite face searches, reverse lookups, or identity enrichment without a clear privacy need. Here is the overall pattern across all 5 stories. AI systems are creating new interfaces to old risk, prompt injection against agents, automated discovery against exposed infrastructure, data platform incidents, faster code changes, and privacy exposure at scale. The confirmed facts differ by story, but the defensive direction is consistent. Reduce what is exposed. Reduce what any one token, agent, or service account can do. Label remaining risk honestly. Watch outbound data. And when AI is in the loop, remember that untrusted content is not just information. It may be an attempted instruction. Final takeaway: if you are building or buying AI tools this week, ask 4 questions before connecting them to real data. What untrusted content can the model read? What private data can it see? What tools can it call? And where can output be sent? If the answer to all 4 is everything, pause. Add boundaries first. That is how AI agents become business tools instead of accidental data leak machines.